Welcome to Mathosynthesis, where I break down complex mathematical problems into smaller, understandable forms. I also take a critical look at your math worries, ease them, provide a solution, and leave you happy thereafter. If you would like to go on this mathematical journey with me, why not join the bus and let's take a ride together. On this episode of Mathosynthesis, I will be looking at my top 5 questions on indices and logarithm. Here are my top 5 questions in perspective. Now, question 1. If 3 to the power of a equals to 4 to the power of y, and 5 to the power of y equals to 6 to the power of z, then what is the value of x over z? Question 2. If n to the power of x dot n to the power of 8 equals n to the power of 24, and n to the power of 6 bracket the power of y equals n to the power of 18, what is the value of x plus y? Question 3. If you have 3 variables a, b, and c that are consecutive positive integers, and such that 2 to the power of a times 2 to the power of b times 2 to the power of c equals to 512, then you should calculate the value of 2 to the power of a plus 2 to the power of b plus 2 to the power of c. Number 4. If log x to base a equals s and log y to base a equals t, then what's the value of log xy to the power of 2 to base a? And lastly, number 5, should evaluate 5 to the power of minus 3 log 2 to base 5 multiplied by 2 to the power of log 3 to base 2. Now let's take a look at the question one after the other. Now these are sample questions from standard exams, so I've provided the options so we can see whether we are in line after our solution or not. So you have options to question number 1 now. A log 3 over log 3 log 5 over log 4 log 6. B log 4 log 6 over log 3 log 5. C 1. D log 4 log 6 plus log 3 log 5. And E log 3 log 4 log 5. So let's take a look at the question again and see how we take the solution one after the other. Now, how am I going to approach this problem? Now, the way to approach it is you have to linearize the exponential equation, meaning that you must bring the exponents, the power, you have to bring it down. And how do you go about that? 1, you have to apply logarithm. You apply log to bring down the exponent such that you now have a linear equation. Now, if you look at the question, we're looking for the value of x over z. So we have to solve the resulting linear equation now in a way such that the variable y is eliminated. So by the time we do that, we'll be able to express the value of x. Now let's look at it in clear terms now. So if we apply log to 3 raised by x and 4 raised by y, you have x log 3 equals to y log 4. You can call that equation 1. Similarly, we also apply logarithm to the second expression, which is 5 raised by y equals 6 raised by z. If you do the same thing to that expression, you have y log 5 will be equal to z log 6. Let's call that equation 2. Now, what do we need to do? Like I said, we have to proceed to eliminate y so that way we can obtain an expression for the value of x over z. So what do? We'll take our equation 1 and find an expression for y. So that means dividing both sides by log 4. So we have y equals x log 3 over log 4. Let's put that as equation 3. In the same vein, our equation 2, which is y log 5 equals to z log 6, we also make y substitute the formula so that you have z log 6 over log 5. You can also put that as equation 4. So to eliminate y, we can just equate the two equations 3 and 4 together. So we have x log 3 over log 4 equals to z log 6 over log 5. Now, we are almost at the end of the journey. What is left is now just to make sure you have x over z on the side of the equation. So we can put z down in this manner. So you have x log 3 over z log 4 equals to log 5 over log 6. In the same vein, you can also bring log 3 down and log 4 up on the other side of the equation. So that way you have log 6 log 4 divided by log 5 log 3. Another way, of course, is you can say that you multiply both sides by log 4 over log 3 and divide both sides by z. It's going to come to the same expression. So either way, you are very, very much in line. So finally, the value of x over z is log 4 log 6 over log 3 log 5. Now straight to question 2. Now question 2 is another expression, exponential expression, equation, and we're asked to, in this case, calculate the value of x plus y. Now let's look at the options. So we have A7, B9, C12, D19, and E27. So how do we go about the solution? This is slightly different from question 1. The difference in this question and question 1 is that in question 1, the bases are different. I mean, you have 3, 4, 5, 6. But in this case, you will observe clearly that they have the same base of n. So what do we do? Now, the approach is, now since the base n is the same throughout the equation, then basic laws of indices can apply. Now recall the laws. A raised to power b dot a raised to power c equals a raised to power b plus c, and a raised to power b raised to power c equals a raised to power b multiplied by c. So you just need to use these two laws and break down our expression. So what do we do now? So using that approach, n raised to power x dot n raised to power equals n raised to power x plus 8 plus n raised to power 24. So since the base are the same, we can equate the exponent. We can like compare the exponent. So we proceed to say that x plus 8 equals to 24. So that way x is 24 minus 8, x is 16. Similarly, applying the second law there now, that is n to the power of 6 multiplied by y equals n to the power of 18. Similarly, like we have done in the first expression, we equate the powers. So 6y equals to 18, y equals to 3. So x is 16, y is 3, so x plus y will be 16 plus 3. I will get our answer to be 19. This is a very interesting problem, and it's not as difficult as it might look or seem. Now question 3. This is a very interesting problem because we are dealing with integers now. So you have a, b, and c are consecutive positive integers, and we're given an expression. We're asked to find another expression. So how do we go about it? So I put this kind of problem. Let's get the key information from the problem itself. Now when you say consecutive integers, they are just successive integers with a common difference of 1. For instance, like 1, 2, 3, 5, 6, 7. Now, also, the integers are A, B, and C. So that means that B is 1 greater than A and C is 1 greater than B. So such that you can have it that they can be written as A plus 1 and A plus 2. Now what do we do to the expression? There's a common base of 2. You can identify lots of indices. And what we do, we solve the equation in terms of the smallest positive integer, in this case which is A. And if we're able to solve for A, we can solve for B and C, since B is A plus 1 and C is A plus 2. So let's go on from here. Now 2 raised to power A times 2 raised to power B times 2 raised to power C is 512. So indices, that's 2 raised to power, that will be 2 raised to power A plus B plus C and equal to 512. So 512 of course is also 2 raised to power 9. So we can say A plus B plus C equals to 9. And B is A plus 1 and C is A plus 2. So we put that together, that will give us also 3 plus 3 equals to 9. And we get our A equals to 2. So B will now be A plus 1 to 2 plus 1 equals to 3. C will be 2 plus 2 equals to 4. So our expression can now easily be calculated. And we have our 2 raised by A plus 2 plus B plus C equals to 4 plus 8 plus 16. And that will give us 28. So it's a very straightforward problem, especially even that the base is common. The only key thing there is understanding that they are positive integers and that they are consecutive. That's the key to solving the problem. Now to question 4. Question 4 is a logarithmic problem and it's easy. If log x to base a equals to s and log y to base a equals to c, using these two information, we want to find the value of xy to the power of 2 base a. So given options a bracket s plus t, b bracket s plus t, c 4st, d 2st, and e st. So let's solve the problem. Now how do we go about it? It's a very basic question, not difficult, because also the bases in the two logarithm expressions are the same. So what do? We have to break down the expression first that we want to find the value for. So recall there's a law of logarithm where if you have log e to the power of r to base p, it will become r log q to base p. So using that, log xy to the power of 2 to base a will be 2 log xy to base a. Meanwhile, there's another law that has that log q to base p plus log s to base p equals to log qs to base p. So if you take our log 2 log xy to base a, you can break it down to log equals to 2 log x to base a plus 2 log y to base a. But we already were given that log x to base a is s and log y to base a is t. So we just need to replace the expression with s and t. So that will be 2s plus 2t. So therefore, our value of log xy squared to base a equals to 2 brackets s plus t. You can see it's an interesting problem, not difficult. The key thing here is that you start from what you are required to evaluate. And lastly, for me, the most interesting problem and sort of most challenging problem on this episode of Indices and Logarithm. But the question is a combination of indices and logarithm They both combine together. We have options A, B. A is 8, B is 1 over 8, C is 2 over 5, and D is 1 over 8. So how do we go about this interesting problem? Now, the best way to go about it, of course, is to first of all bring down the heavy load on base 5 and the heavy load on base 2. So let us treat the logarithm separate. Let's break it down. Now, using the fact that a log b to base c is log b raised by a to base c, so we can evaluate the logarithm first. So minus 3 log 2 to base 5 will be log 2 raised by minus 3 to base 5, which is log 1 over 2 raised by 3 to base 5. And that will give us log 1 over 8 to base 5. In the same vein, 2 log 3 to base 2 will be log 3 square to base 2, and that is log 9 to base 2. Now, having evaluated these two expressions, to put them together, it means our expression is equals to 5 raised to power log 1 over 8 to base 5 multiplied by 2 raised to power the log 9 to base 2. So, how do we proceed from here? So what is the value of the expression a raised to power log b to base 8? So let's put it equal to x. Now if you apply the logarithm on both sides, so the way what we're trying to do here is to break down the power or the exponent of the base a. If you do that, log b to base a can come down. We have this expression now, but don't also forget log a to base a equals to 1. So putting that in mind, we have log b to base a equals to log x to base a. And since the base are the same, we can simply equate b equals to x. So what does that tell us? It means a raised to power log b to base a equals to b. So anywhere you have the exponent and the base have the same base, the value of the expression is just the number, in this case b. So we apply the same idea now to the expression I want to calculate. So 5 raised to power log 1 over 8 to base 5, so that will be 1 over 8. And 2 raised to power log 9 to base 2, that will be 9. So we have 1 over 8 times 9 equals to 9 over 8. And our answer will be 1 over 1 over 8. So this is how to approach this expression. It looks a bit difficult, but when you understand the rules, you will know how to get out of the problem. Now, this is an exercise for you. Number 1. This is similar to one of the questions we have looked at. If log x to base a equals to n and log y to base a equals to p, evaluate the value of log x square y to base a. Give a np, b 2np, c 4np, d 2n plus p, or e 2 bracket n plus p. Now also, what is the question 2? What is the set of all values of b that satisfy the expression or the equation x raised to power 3 bracket 4 minus b squared for all non-zero values of x? Is it a 0, is it b 2, is it c 4, d minus 7 and 7, or e minus 2? And lastly, you have question 3. Now, whenever w is an integer greater than 1, then log w square over w c to base w equals to what? Is it a minus 4, b minus 3, c minus 1 over 3, d 1 over 3, or e 1 over 3? Now, I want to try hands on these problems. Try hands on this problem. Put your answers in the comments below. And if you'd like to have a solution to the exercise, you can send me a mail at the address mathosynthesis@gmail.com. Now also, you can also follow this work on social media platform. On YouTube, try to subscribe and click the notification button so that you can get more videos. Also follow us on Facebook, Twitter, and Instagram. I hope you enjoy the lecture so far. If you do enjoy, let us know what topic you want.